This is TechTalk Hotel Backend. Usually we do this team internally, but we were quite interested in Bitcoin and blockchain. And so I talked to Jacek Janczura, who also works at idealo, if he could make a presentation for us. And so we thought, hey, why not do this for everyone at idealo? We have a 30-minute presentation from Jacek first, and you have the chance to ask questions in between, like he has 3 time slots for that during the presentation. After that, we have a discussion round for about 25 minutes, and we finish off with a little feedback. Since this is my first hosting of such a meeting, I'd like to get feedback from you, and also you can give Jacek feedback. Yeah. So some of you might know me from my videos, and I couldn't help it but prepare a little bit of a teaser for Jacek and what an amazing person he is. And yeah, so here it is, the teaser for Jacek Janczura. TechTalk Hotel Backend. Today, Bitcoin and blockchain, with our special guest speaker, Jacek Janczura. At idealo, he works as a backend developer in loyalty. In his free time, you can find him on conferences as a speaker talking about his passion, blockchain. Privately, he also likes to reach high. He is a certified skydiver and jumped more than 40 times out of planes. But today, he stays on the ground for us. Give a warm welcome to Jacek Janczura.
So, hi everyone. Let me share my screen. Today, my presentation will be about blockchain and Bitcoin. I'm Jacek Janczura. I'm software engineer at idealo, currently at Team Postman from Acquisition and Loyalty. And today, I want to focus mostly on the basics of blockchain, how it works, what it is. And at the end, we'll do some short, briefly presentation about Ethereum and how to use actual blockchain, because Bitcoin cannot be really usable. But about that later. Let's start about the basics. So what is it? Hash function and Merkle tree. Hash function, you probably know SHA-256. Hash is changing the output of variable length into fixed length, input of variable length into fixed length output. So the input text will be this hash, as you see in the screen. And what is very important in hash is that you cannot guess what was the input, and you cannot easily find the hash output of the string. So it's super important. And another important thing are hash collisions, which is like you can imagine that we have some known hash, and you cannot easily come up with the string that will give the same hash output. And the other very important basic thing is a Merkle tree and fast integrity checks. So Merkle tree is a tree of hashes. So we've got data A, B, C, D, and we hash data A, we hash data B. We've got both hashes here, and we then hash those hashes into hash AB. The same for data C and D. And at the end, we've got a root hash, which is the hash of AB, CD, which is hash of ABCD. And why it's important? It's important for fast integrity check and identification of corrupted data. In case we try to corrupt data C or change something, even 1 bit, this hash will be different, this hash will be different, and a root hash will be totally different. So it's super important. Okay, let's do some demo. Let's first show how it works. So this is first block. As you see, hash is changing. All the time I'm typing something. and this is hash of this string. So let's copy this. This will be the beginning of our blockchain, and this is its hash. Let's copy string. Let's say Jacek sends Martyna 10 Bitcoin. We take that, we hash it, we take that string. This is our hash. So we copy it, and we can start a new block. Let's say in this block we'll have idealo TechTalks and Martyna sends Jacek 10 Bitcoin back. And we take all that stuff, we hash it. We hash it, and we've got a completely new hash. It means that in case I changed any byte in this string, the initial hash will be completely different. So let's add additional block. In this block, give me some example of string, whatever. Jonas, help me.
Send Tilo 10 Bitcoins.
Okay. Send Tilo 10 Bitcoin, and we hash.
Your connection is a little bit bad.
We've got a new hash in here. And we've got the hash of the previous block. So what it means, what is it about in here? Imagine I'm changing some data in the first block, and when I change the when I add k here, this hash will be different. This hash will be different. This hash will be different. This hash will be different, and the whole and it will be super easy to spot what was changed. Or rather, each block was corrupted. So that's the whole idea behind the whole blockchain. It's just a set of hashes, and there is in the new block there is a hash of the previous block. That's it. That's the whole complicated blockchain. And when I was looking at the videos in the internet, trying to introduce people to blockchain, and all of that was like so complicated and so abstract. And this is, in my opinion, a really interesting idea how normal people without very advanced knowledge can imagine blockchain. So let's go back to the presentation. Of course, it's not the end, because there are more things to know before we go to Bitcoin. Okay, so what is blockchain? Blockchain is append-only registry. So you cannot remove data without leaving a trace. So as you saw in the example, when I changed one letter in this is first block, and I add k, whole hash is totally different. And I add something new, whole hash is totally different. I add something new, even one letter, the whole hash is totally different. You can even hash the whole contents of, I don't know, of some code from GitHub, and this all code will be this hash. And if I change this letter, this is totally different hash. So block is append-only registry, and you cannot change or modify already stored data without leaving a trace. You can verify integrity blockchain yourself, but to verify integrity, you need to have the whole blockchain. So the previous blocks. So to check if send Tilo 10 Bitcoin you need to check the whole blockchain if like everything was if the hash root is okay. So that's as well very important. And now let's talk briefly about Bitcoin. In Bitcoin, in the beginning of 2021, we have already 660,000 blocks, and it's 311 gigabytes of data. So it's a lot of data. That's why it's quite important to and quite complicated to do these integrity checks, because only you can do it when you have those 311 gigabytes of data. And in one block, to because like the size of the blockchain will grow in relation to the size of the block. The more transactions you've got in a block, the faster the blockchain grows. So currently in Bitcoin, a number of transactions you can add to the block is limited to between 1.5 or to 2,000. Okay. Peer-to-peer networks. Before we start talking about Bitcoin, it's super important to understand how all those nodes cooperate with each other. So the whole Bitcoin network is just an example of peer-to-peer network. And peer-to-peer network is a network that relies on the computing power of the clients, of the peers, participants in the network, rather than the network itself. What does it mean? It means that the nodes function simultaneously as a client and as servers. So when the new node is joining the network, he sends this information to all other nodes. In Bitcoin, there are nodes that are holding the whole blockchain. They are called fast FAT nodes. They are as well nodes that are light nodes, which are just causing the fraction of the data, and they are checking the current transactions. And there are mining nodes, which are doing this magical proof of work mining, and they earn some reward in Bitcoin in return to their computational power to like protect the whole network. And a very well-known example of peer-to-peer network is BitTorrent. So probably all of you know what torrents are. The data is we put the data, one big block of data into smaller chunks, and those smaller chunks can be distributed over the network. And when someone wants to download the whole, I don't know, video, this person can download these chunks from available nodes in the network, and chunk by chunk from different servers. So when one server is down, there are other servers that are taking over and letting you download something. So this is super important because that's the basic for the the Bitcoin network. Okay. Any questions so far? Okay, good. Centralized registry, because I previously said that Bitcoin is, or like blockchain is decentralized registry. So what is centralized registry? Centralized registry is, for example, bank that keeps all the data itself, and keeps the data like A deposited $1,000, B took 15K credit, bank charged the $100 loan interest, and C deposited $10,000. And for example, E have $200 on his account. That's a centralized registry. What is distributed registry? Please imagine the group of friends. In this case, there are 6 friends, and all of those friends, they have a piece of paper. They have piece of paper, or rather notebook with multiple papers, and each of the friends is shouting the transactions they are doing in between each other. So A is shouting, I'm sending, or I'm giving a D $10, and all of 6 participants note that down. A sent D $10, and then D is shouting, I'm sending E $15, and all participants are noting down D sends E $15. And what happens if the piece of paper finishes? Any ideas? We, of course, hash it, so the transactions cannot be changed. We take a new page, we turn the page to the new page, and we start saving the transactions again. C, send, F, 5 bucks. And at the end of that page as well, we hash it, and we have blockchain as well of the transactions. So all the new blocks are joined with the previous block by its hash, like I showed in the example. What happens when a new friend wants to join the group and wants to participate in the system? When new peer joins, they take one page from different peer. So they don't want to rely on one peer, because then this person can cheat or mess with the transactions, hash them again, and create the blockchain again and send this fake blockchain to the new person. In this case, when the new peer joins, they take one page from each person, and in case they do the whole hashing themselves. So they check each transaction, each page themselves, and if they find that something is wrong, they take this page that was wrong from another person in the distributed registry. And until 51% of participants in the network are trustworthy, the whole blockchain works. Okay, we are very, very close to Bitcoin. So now let's talk about asymmetric encryption and signature. I know I will do massive simplifications here, and generally in this presentation, I'm doing massive simplifications. So in case you want to do something with blockchain, don't rely on it. This everything in here is simplified. I don't have time to like elaborate on asymmetric encryption and different algorithms, because like it's a material for like one semester lectures. So like just trust me. Asymmetric encryption is like you create two types of keys, one public and one private key, and you can encrypt the data with one and decrypt with the other. Public key can be shared with anyone else, and until a private key is not disclosed, it means that only the person who owns the private key can encrypt or decrypt the data. So we know that when someone encrypted some kind of data with private key, this person had this data before, because only this person can do it. And what is hash? What is a signature? It's super simple. We take the piece of data, we hash it, so the data cannot be later modified, and we sign the hash. And what does it mean, sign the hash? We just use the private key to encrypt the hash, and anyone with our public key can decrypt this hash and can hash the data themselves and then compare the hashes. If the hashes are the same, it means that this is the piece of data that was signed by the signer. Is it clear so far? Okay. So, and in here I start with deadly simplifications. Let's imagine in blockchain, public key is just a wallet address or a blockchain account number. So a public key can be shared with anyone, and until we don't disclose our private key, anyone can send the assets to our account just using our public key. And we can access the assets by having private key and giving a proof to the network that we are the owners of the private key, so we can access the assets. And to send transaction, we need private key, because we need to provide a signature with our private key that we are doing the transaction. And to send Bitcoin to the recipient wallet address, we need just their public key. That's it. Okay. Any questions so far? Okay, good. Let's talk about proof of work and regulation of difficulty. So, of course, there are many people who want to participate in blockchain, but somehow we need to pick people who can add new blocks, and we cannot do it randomly, or it won't make any sense to I don't know, based on someone's I don't know, mood or whatever, give him the right to put the new block. So there was a designed algorithm called proof of work that we give a puzzle to all peers who wants to participate in mining. And the first peer who solves the puzzle can add a new block to the blockchain. So in this case, the puzzle is number of zeros at the beginning of the hash. So we've got a text: Jacek sends 10 bitcoins to Martyna, and this is hash of this string. And when we add number 1 at the end, there will be 0 at the beginning of the hash. So when you come up with some string that you need to add to that main message, and you have a 0, it means that you solve the puzzle. And of course, since this is SHA-256, and this is so it means that it's like set of ones and 256 ones and zeros, and in this case is a hexadecimal representation of that hash, which means that we've got 16 possibilities to find 0 in here. And the complexity of this puzzle is growing exponentially. So the more zeros we have, the faster complexity starts to increase. So to have 2 zeros, we need to add to the string 1394, and number of possibilities is 16 times 16, which is 256. And when we add a third 0, it's already 4,000 possibilities over. So 16 times 16 times 16, and 40 times 16. So it's even more. And you need to add that string at the end of Jacek sends Martyna 10 bitcoins. And currently, complexity is, I think, something like 74 trillion possibilities to find the string, to find this additional number at the end, to have the zeros in the hash. So it means that it's almost impossible to come up with it without massive computational power. And in Bitcoin, there is an algorithm that is evaluating time that took peers to create a new block. And based on the hash rate, so number of hashes the network is guessing, the computational power, so which means the required, so which means number of zeros in the hash. So the puzzle is getting more difficult or less difficult. So the network wants to keep complexity on about 10 minutes per block, which means that with the current computational power in the network, new blocks should be added every 10 minutes. And the network is regulating the power, the complexity of the puzzle. Okay, got a bit more complicated, but you've got the main idea. And why new transactions are added? Because I said that miners, so the people who share their computational power to protect the network, get a reward. Currently, the reward is 6.5 Bitcoin, which is around 200,000 euros for person who found this, who solved the puzzle. So it's quite a lot, and there are many people who wants to do it. And there was a problem because actually you don't need to add new transactions to the block to get that reward. You just solve the puzzle of empty block, and you get a reward. So so there needs to be an incentive for these mining peers to add your transaction, and there is, and of course people are greedy, so they don't want to do it for free. There is a transaction fee, so a little amount of money that you need to pay to the miners to add your transaction. And you see that if you specify zero, it's Satoshi. Satoshi is 1 to the power of, I don't know, 19 of Bitcoin. So it's like very little, very little fraction of Bitcoin. So if you pay 0 Satoshi, there is almost no possibility that your transaction will be added to the blockchain. If you add 1 to 30, your transaction will be added either after 50 minutes or never. And when you add 500, your transaction will be added between 0 or 45 minutes. And the more you pay, the easier it gets to add your transaction to the blockchain. So that's the incentive. You just need to pay to add your transaction. Okay. So let's finally talk about transactions and Bitcoin. As we talked before, in a Bitcoin, we've got a block header. In block header, we've got a previous block's hash. So to keep the integrity of the blockchain, we've got a timestamp of the person who solved the puzzle. We've got the nonce. Nonce is this number at the end that you somehow guess to obtain those zeros in the hash. And you've got a Merkle tree root of the transactions, which means you've got transaction 1, transaction 2, transaction 2000. You hash them, you build hash of them, you hash the hashes, you hash the hashes, and you've got the hash root of those hashes. And in case someone tempered one of the transactions, the root hash will be totally different. So it will be super easy to check the integrity of the transactions and the corruption of the data. And you hash it, you've got this hash with zeros at the beginning, and you add it to the new block, and you try to guess the nonce. Of course, there are different algorithms. Some are doing from 0 to infinity. Some are guessing random numbers, different ways to do it. And let's talk about transaction lifecycle, because it's as well very important to introduce how actually the transaction is added and how you prove that you own something. So when transaction is created, signer, the owner signs the transaction, which means the owner is using their private key to encrypt the hash of the transaction. Then the transaction is validated. What it means that transaction is validated. Blockchain doesn't hold the information that Jacek owns 100 bitcoins. Blockchain knows only that that there was a transaction that paid to Jacek's account 10 bitcoins, and Jacek can spend his 10 bitcoins only when he got some bitcoins. So Jonas, you cannot create a transaction which states Jonas sends to Jonas' new address 10 Bitcoin, because there was no transaction that gave you this 10 Bitcoins. So during the validation period, your transaction will be discarded. If your transaction is correct, which means somehow you had those Bitcoins on your account and you've got enough Bitcoins to send to network, your transaction will be further propagated. Then it will be verified and recorded into blockchain. Of course, if you paid enough fee, confirmed and validated again. Okay, any questions so far?
So you said that you have to pay for your transactions. Does that so and your transaction might not even go through, right?
Right.
Okay.
So we need to pay enough. There are of course estimates what is current average transaction fee, and you can estimate how long your transaction needs to be added to the blockchain. So there are already private key managers. I will show it later, that they store your private key and they help you making transactions and estimate the transaction fee.
Okay. Yeah, because like I was a little bit thinking about, okay, some people say Bitcoin is like, yeah, a way to remove banks in the future. But I was thinking, okay, if I cannot be sure that my transaction goes through, is that really an alternative then? And that's kind of my question a little bit to you in this case. Like, do you think that's possible? Or
blockchains which are insanely cheaper, and when you actually send a big transaction like 10 million euros, you pay 10,000 euros fee for that to the banks. I don't know if you knew about it. And if you send 10 million euros in Bitcoin, you pay just I think it's $10 of transaction fee. But there are other cryptocurrencies which are much cheaper and which blockchains are much faster. So like Bitcoin is just a grandfather for all the other cryptocurrencies. It was created in 2009 by unknown creator Satoshi Nakamoto. And until 2011, we don't know who this guy was. And in 2011, this guy stopped answering in the forum. And he mined a few million of Bitcoins. And they are in the network stored in the wallets, very, very, very old wallets in one of the first blocks of the blockchain. And there are like massive number of Bitcoins stored in a blockchain, but owners lost their private keys, so they cannot access, so they cannot sign new transactions, actually. So that accessing your account is just signing a new transaction.
Okay.
Any further questions?
I have another question about the validation. You said that the actual state of your account is never stored, so you have to look through the whole blockchain.
Yes.
And how is it done efficiently? Because I think
there are different types of peers. Of course, you've got these fat peers that are storing the whole blockchain and the whole replication of the network. But there are light peers which only verify the last few blocks. And if you've got a few thousand of those, you can be quite sure that you're not cheated. And at the end, when the when the transaction is added to the block, it's fully verified. The integrity of your transaction. It's not that hard. It's quite simple to do this binary search.
Okay, I think we can continue and do the other questions at the end.
Where can I use Bitcoin? Bitcoin can be used in ransomware payments. When someone encrypted your company's servers, you can pay ransom in Bitcoin. You can buy illegal items in darknet. You can buy it as an investment for holding. And to be honest, I personally don't see other uses for Bitcoin, because its price is fluctuating so fast, and you cannot really make your monetary system dependent on Bitcoin. But there are alternatives, and one of the alternatives to Bitcoin is blockchain called, for example, Ethereum, where you've got Turing complete language, and you can store code in the blockchain, and you can execute that code with the transactions. So let's go maybe to an example. I'm a bit geek, and when I got married, I wrote a wedding contract. So apart from getting married in the city hall, I wanted to have an eternal copy of my marriage. So I wrote to my wife a wedding contract. And let's together see how you can deploy a contract. This is super simple wedding contract. You can, of course, have much more complicated logic and store it in blockchain and have some kind of checks and so on. This was just a contract to store strings. So in the constructor, I have husband address, husband full name, wife address, wife full name, and the wedding date. And apart from that, I've got a few functions to sign a contract, to add a hash of the written contract. So we got, of course, the written contract from the City Hall. We scanned it. We make a hash. Actually, it's a hash for IPFS file system. It's like this distributed file system. Never mind. And you can store it in this contract. And as soon as there is a contract stored, and the both husband and wife sign the contract by like executing sign function, the contract signed, and you can have a blockchain wedding. So let's compile it. Okay, it was compiled. So now let's deploy to blockchain. I created 2 accounts. I created Jacek's account and Martina's account. Let's create a blockchain from Jacek's account. I've got 10 Bitcoins on that account. So this is husband account number, husband full name, Jacek Janczura, wife's address. And by the way, this is MetaMask. MetaMask is a really cool password manager for blockchain. It allows you to have multiple accounts and easily make a transfer. So, for example, I want to transfer from this account to this account 5 ETH. I press next, and there is estimated gas cost. It's like this transaction fee. It helps me to estimate how fast the transaction will be added. I want fast, and I want slow, and transaction is pending. And soon the transaction will be added. So from this account, you will see that it's not 106 ETH, it's less. And in that account, oh, it's already passed. So in that account, we'll have more. So 6 in that right now. Okay, let's deploy that contract. We've got wife's address. I didn't copy it. You see the confirmation. So what MetaMask is doing is just a password manager for blockchain. Wife's address, wife's full name, Tina Rafalska, and wedding date 16.10.2020. And you transact. I confirm. So this automatically asked MetaMask if I want to use this account, my account, to deploy that transaction. I agreed, and the transaction is already deployed to the blockchain. Actually, I think you can see this in public Etherscan. So Etherscan is like a way to see the transactions and see the blockchain. So the transaction is being confirmed. Oh yeah, and it got confirmed. So there is a binary code for that wedding contract, and that's the contract address. And you can interact with this address. You've got the compiled code, swarm source, and you can as well throw some events, so you can hook your application on the events in the blockchain. No text. Yeah. Okay, so let's now try to interact with this smart contract. Let's propose a written contract. So this is some hash of written contract. We propose the written contract to the network. We, of course, we are asked by MetaMask to confirm that this is the transaction fee for storing that data, and we send signature. Transaction is pending, transaction passed. Okay, we can access written contract. This is our hash stored in that class, in that smart contract, and we can sign the contract. So since we proposed a written contract, we can now sign the contract. We confirm. We log to another account. So if we try to sign from unknown account, the transaction will be rejected. This is my account. Let's sign from my account. Confirm. And transaction didn't pass right now. Wait, need to wait a bit. Transaction failed. Yeah, I didn't specify enough gas fee, but yeah, you know the point that if you don't specify enough fee, your transaction can fail. And what is because like you store some code in blockchain, right? So you can as well create a infinite loop, and you will basically DDoS the whole network. So how Ethereum blockchain is protecting itself against DDoSing is by creating some kind of gas. Gas is like the gasoline in a car, and you can send some gas, which is like part of Ethereum, and it's the fraction of computational power to trigger that transaction or to trigger some for loop. So the more complicated your transaction is, the more complicated functions are in your contract, the more computational power it requires. So the higher fee you need to execute the transaction. Okay. So thank you very much, and it's time for questions.
Yeah, thanks, Jacek. Yeah, are there any questions from the audience? We still got a question from Konrad from earlier. I did see that before. Where is the amount of Bitcoin stored in the block?
So in blockchain, you don't store amount of Bitcoins. You store just the transactions. So you know that some miner got a reward from the network, and then the miner sends that money to some kind of exchange to sell it to someone else who can offer them fiat money, which is like euros, and that new person will have this 10 Bitcoins in his account or 6.5 as a reward in his account, and then this person can send the Bitcoins to another person. So you don't store the number of Bitcoins on your account, you store the previous transactions that happened, that ended up in you having these 10 Bitcoins. Okay.
Any other? Manu asked, is it true that the Bitcoin network can only validate 7 transactions per second?
I think it's 5. Yeah, it sucks. It's super slow. Visa, for example, can can create 4,000 transactions per second, but there are alternatives. So there is something called Lightning Network, which is creating little blockchains it's off-chain. So there is the main chain. You create a little blockchain off-chain. So between you and your, for example, customers, in case you've got a shop, people pay or buy something, pay you, or you pay something to other people. So you do that thousands of transactions, and then you can scale it up infinitely. And then you settle your account at the end of the day and send all the transactions to the network. Network is validating everything. So the final results of your wallets, and this is added to the blockchain. And there are other blockchains which are much better than Bitcoin. That's why I stated that really Bitcoin doesn't make sense. And there is another problem with this proof of work. So basically, number of computational power to protect the network. Right now, it's insanely high, and it's too much we need. So basically, 70% of computational power is used for Bitcoin is wasted because people are greedy. There are like thousands of people around the world who are mining Bitcoin. There are massive mineries in Russia, in China, in South America, where they have electricity for free from like massive coal plants or massive solar panels, and they want to participate in it. So they join together in like this mines, and then mines join together into the mining pools. So they have together more computational power, and then they share this reward between each other. And this algorithm is stupid, and in my opinion, and it's like 2019 first idea for it. And right now there are better types of consensus. There is proof of stake, where you put some money to the escrow, and if you cheat, you lose your money. Or there is proof of authority for private or corporate blockchains, where in case you want to send something, or there is a cooperation between companies. And we implemented quite interesting use case for that for Posta Italiana, Deutsche Post, and DHL, DPD, something like that, where they were sending packages of really high value, and companies don't really trust each other. And in case of centralized database, in case you broke €1 million package of vaccines, you just pay admin 100K. Admin is deleting record in the database, wiping up the logs, and no one knows what happened to those vaccines. And in case of blockchain, especially in the case of this private blockchains or this consortium blockchains, you cannot delete or modify anything without leaving a trace. So all parts of the consortium see that you mess with the data, or see that you try to do something illegal, and then you are no longer using proof of work. You're using some other algorithm which lets you to scale your throughput to 5,000 transactions per second, not 5 or 7 or 10, which is ridiculous.
Okay, thank you very much. Okay, How has a question? I have a question regarding the smart contracts. You have shown that the code is stored as a binary in the blockchain. Is it possible to compile, I guess it's compile it into human readable code?
Yes, sure. It's fully possible to decompile it to human readable code. You can as well publish your code in a blockchain, because this is called public blockchain. So when there is code stored in a blockchain, it's public, and it's possible to decompile it. Of course, it's hard, but Solidity is very low level language, so there are underflows, overflows. There are many attacks on different contracts or on different ICOs. So this new tokens, people lost lots of money because of bad written code. But yes, all code you store in blockchain can be decompiled into human readable code. But there are ways to keep private transactions or to keep stuff private, especially in consortium blockchain, where there are many companies cooperating, and they want to share parts only with some subset of the consortium. So there are ways to do it privately, but in different blockchains.
Okay, Manu asks another question to the blockchain network. How is the data synchronized between the peer-to-peer nodes, which hold the whole data without having a centralized registry for IPS?
So basically, when the new block is added to the, so when someone mines a new block, which means solve this puzzle, this person is creating a new block, and it's sending the block to whole network. And then, since it's really hard to solve the puzzle, but it's super easy to check the puzzle, because checking the puzzle is just hashing the whole block yourself and comparing if his none, so this counter gives required number of zeros at the beginning. This block is validated, and if more than 51% of the network agrees on this block is added to the blockchain. And there is as well consensus. So when two miners mine the same block in exactly the same time and send the block to exactly 50% of the network first miner, 50% of the network second miner, we've got something which is called fork. And later in blockchain, there is in Bitcoin. I'm talking about Bitcoin, not other blockchains. In Bitcoin, longer the new blocks will be added for both, and at some point, one of the sides will have more computational power, and the longest blockchain always wins.
Okay, Konrad is concerned about legal reasons. If it's possible to add any data to the blockchain, how can it still exist in a legal way? E.g., for example, if someone uploads a cinema movie.
Because cinema movie or there were concerns about child pornography, you don't necessarily store like actual data in blockchain, because it will mean that all peers will need to have the copy of this movie. And it will cost you so much that it won't be worth it. So it's even hard to write a proper code. You don't necessarily want to use strings as I used in my contract, because strings cost much more than byte representative of them. And not even talking about movies or pictures. Because the blockchain is fully replicated across whole network. So it means that anything you add to the blockchain is always stored by other peers. There is other way to store stuff in the blockchain. It's called IPFS, which is a peer-to-peer store. So basically, like in torrents, you hash your data, and the hash is direct linked to the data, and anyone who's got the same data, they hash it as well, and they share that this data is accessible from my machine to the network, and you just store in blockchain the hash, so like the pointer to that piece of data. But then it's quite easy to spot the servers which are hosting this data and kill them. Okay.
Okay. Yeah, so one idea I also had, so since we're at idealo, maybe we can do also a little crowd brainstorming. So you already revolutionized marriage contracts. Do you see any applications where we can use this at idealo? Also for the audience, maybe you can write some ideas you have in the chat.
Yes, of course. I had an idea for our hack week. To create idealo-wise tokens, which will to introduce gamification to idealo and onboard users better at idealo. So when you first create price alert, you get 10 idealo coins. When you add, when you create something like review of the product, you get 50 points. When you create a wish list, you get 50 points. When you create 2 wish lists and add 5 addresses, you get something more. So to help users discover idealo on board, add some kind of gamification. Users can get the tokens, and which can be somehow changed to some kind of discounts.
Okay, yeah. So to sum it up, thanks again, Jacek, for your awesome talk. That was really interesting. As a final step, I'd like to do a thing called return of time invested. So pretty much the audience can say, okay, if you give a -2, that means you completely wasted your time here. -1 means, could have used the time better. +1 means, hey, this was quite well invested, and +2 is, man, this was amazing, exactly what I need. Yeah, please write it in the chat. Also, if you want to give Jacek or me some feedback, what you found good and or what we can do better, can also write us or privately or here in the chat. Feel free. Yeah.
And
any last words
from you? Of course, if you want to connect with me on LinkedIn or write me privately, you can scan QR code here or add me on LinkedIn. And if you've got any questions about blockchain, Bitcoin, and how like the word, just ping me.
Okay. We've got one last question. If we want to get into programming smart contracts and blockchain, which blockchain would you recommend?
Definitely Ethereum. There are lots of sources to start Solidity. There is this online IDE I used to show you how to do it, but in Visual Studio Code there are many plugins. There is a Truffle framework which helps you to write unit tests for your smart contracts. Helps you to deploy contracts to the network, to like the Ethereum network. There are many test networks, and the whole Ethereum world is like the easiest to enter.
Okay, yeah, then thanks everyone, and have a good weekend. Thank you.